So what we're showing here today is a concept called virtualized central office. There are many central offices for all of the carriers. Each central office terminates a variety of different types of services. What we intended to do with central offices is actually a huge source of capex and opex. So what we intended to do was actually pick the services that are hosted in the central office and demonstrate those as part of a virtualized platform. This is the onboarding process first that we have. We are onboarding all of the VNFs onto the OpenStack platform, and you have a bunch of Ansible scripts that allow you to onboard the different VNFs, and you can see that this is the VBNG onboarding process that we are going to show. Then the next one is the other VNF from F5, which is the anti-DOS protection. So you will actually, as the video rolls, you will see that there is nothing here first, and then we're going to start off with, running an Ansible script again, and it allows you to now onboard all of the entire VNF fairly quickly. And suddenly now you see that the network config and DOS config VNFs have been onboarded. Next one is the DPI. Same thing, you run through the Ansible scripts, and once the onboarding process is complete, now you can see the DPI as well as the DOS protection VNFs, right? This is what the picture looks like with all of the VLANs that have been created, all of the networks that have been created, and with the entire onboarding process complete. That's how the Azhar Central Office looks like. And here's a pictorial view of that, picture of that entire setup for the network. Next, what we're going to do is now look at the end-to-end service. So first, what we're going to do is get a subscriber to authenticate with the Ericsson VBNG, and the Ericsson VBNG is authenticating that particular subscriber, and then it provides the service. And once it's authenticated, now the subscribers can access any of the services. So that's what we're going to show here, where you're going to take the subscriber. It's basically, again, a scripted thing. It brings up the PPPoE interface, and you can see that once the PPPoE interface comes up, you will see that the subscriber is already now authenticated, and it's able to access google.com. Next, what we're going to see a little bit more is access to social media websites. So let me just stop right here. Here, when you try to access a social media website, then it just gets redirected to an HTTPS and says, okay, you have access that's available. That's kind of standard process how it works today. Now what we're going to do is actually try to execute a policy on this and say, in that policy, our policy says no social networking. So we've created an Ansible playbook to say there shouldn't be any access to any social media website, and we're going to run that particular Ansible playbook. What that Ansible playbook does is it goes and installs policy and on the VNF, not just on the VNF, and the VNF is now preventing traffic from flowing. So what you do here now is that you try to, again, reach Facebook after the policy is installed, the social media site. It says it's closed, connection's closed, no access allowed. And instead, it redirects to a captive portal saying, sorry, you don't have access to this particular website. And then you can do the same thing and say, change it to a secure HTTPS. Does the same thing, and it closes the connection. Now, here's an interesting scenario that we are also showing as part of the residential service. In this particular scenario, what you see is, first, the subscriber is getting full speed access, pretty high speed, and the subscriber is actually downloading something or working on something. Now, at the bottom, you'll see that there is an attacker that's waiting. Now, the attacker instantiates or initiates an attack by sending a bunch of, flooding the network with a bunch of packets. And what you will see here is, as soon as this happens, you will see that the speed for the subscriber starts to go down. And you can see that that comes down to 7K, 3K, all the way down. And now you've detected it suddenly that, oh, there was an attack, and now the speed's going back up. Okay, so you've prevented the attack, you've actually blackholed that particular attacking traffic, and you've shown that the subscriber can get the speed back. So what I've shown you so far is a set of services, right? The residential service and business service. What I haven't shown you at all is how are we going to monitor that situation and where OPNFV really provides that particular. So what OPNFV does, OPNFV provides multiple different services. One, OPNFV allows you first test the scenarios together as part of the Yardstick project. OPNFV also has a service assurance capability through its barometer project. What we've done is on each one of these nodes, we've installed Collectee. Collectee works with Ceilometer to actually collect information and provide that to Grafana to be able to plot that particular information. And what we've been doing is measuring CPU load, memory load, I/O load, and so on. And we can plot that in real time and show that the VNFs or the VMs are getting the service that they need. So in this first video, what we see here is a compute stress test that's going on. So first, we're going to start the service with Collectee, all right? And what we're doing is now stressing the node with some CPU hogs, some IOs, and some virtual memory. So we're going to try to create some noise in the system and see what happens. And once you do that, now you can see that you can actually get the information in real time as part of the Grafana dashboard, and you will see that things have changed. Now, based on this, you can take preventive action, because that's what service assurance is all about. And this is the critical capability that OPNFV provides as part of the barometer project. And you can see that the various different BNGs, you can look at the stats for all of those, what the packets are, what the system's doing, where it is, and how it's rolling. That was using OPNFV barometer to actually ensure that we're delivering the service that we wanted to for the entire residential service use case, as well as the business service use case.